Given f of x equals x squared minus 1 over x minus 1. You know when you look at that function, I don't want to simplify it. I know I can simplify that. But if I don't simplify it, what is the value of this function when x equals to 1? Undefined. So I have to say x cannot be 1. So the question, can you tell me what is the limit? We write that LIM, abbreviation for limits. What's the limit of f of x as x approaches the 1? What are we asking you? Where is the y value going to as x approaches 1? As x gets close to 1. Well, when you say gets close to 1, do you mean from the left side or the right side? If I graph that function, and I did bring my graphing calculator for that reason, y1, clear it. Here we go. X squared minus 1, it's going to be a straight line, you'll see it, divided by x minus 1. When you graph that, you're going to see a straight line. It's not really accurate. The reason you see a straight line because the calculus says, you know what, I can simplify that. How do you simplify it? What the calculator did here, it took that problem, x squared minus 1, and factored that. Isn't that x minus 1 times x plus 1, the difference of two squares, when you factor it? And you divide that by x minus 1. Can you simplify that? The x minus 1 cancels the x minus 1. What's left there? X plus 1, and that's what they graphed. So what the calculator did, it didn't pay attention to this. It actually simplified the function, graph that. Because if you graph it the correct way, you should have a hole when x equals to 1. If you want to get the true graph of this function, you need to know what is going on as x approaches the 1. So my graph actually, it will be, the x plus 1 is really my asymptotes. X plus 1 has a y-intercept of 1, a slope of 1, so something like this. And as x approaches the 1, my function is undefined. I'll make that a red line. Can't cross that line. The function is undefined when x approaches the 1. The graph, I'm not sure what is going to happen to the graph. I have a feeling, I might be wrong, but I have a feeling the graph looks, the asymptote means you're approaching that line. When x is 0, that's a 1, right? It might look something like this. Steep one comes down. Very steep. And on this end, it might look something like this. I'll know in a second. Instead of just a straight line. How would I know what the graph looks like? I need to know the limit. As I approach x from the left side, where is the y value going to? If it says going to negative infinity, I know it's dipping down. If it says going to plus infinity, I know it's going up there. So how would I know if it's going toward negative infinity or plus infinity? We make a table. We try a table. And I have, again, I don't know if the graph looks like this or not. I have no clue. I didn't pick points. But if we try to graph it, here we go, x versus f of x. Let's pick values for x. Let's start from the side here. X, you're approaching the 1, right? From the left side. Let's start with a negative 1. Let's get closer to it. Let's get close to -1. Maybe we'll go to maybe what? 0. I can't let it equal to 1. Let's get closer to that 1 there. What should we make it? 0.9? Get a little bit closer. 0.99. Get closer. 0.999. And so forth. So you're getting closer and closer and closer to it. To the 1 from the left side. I'm approaching 1 from the left. To indicate I'm coming from the left, I put a minus sign now. See that minus sign? It says I'm coming from the left side. That doesn't mean negative. From the left side. Plus means from the right side. Minus means lower than the value. You're coming from the left. And let me go to my calculator and see what will happen when x is a -1. Into this one. Okay, where's that? I can get these answers quickly. Where did it go here? Where's my table? Table. So let's try the -1. For -1, when x is -1, what do we have? The answer is 0. When x is 0, the answer is 1. When x is 0.9, the answer is 1.9. When x is 0.99, the answer is 1.99. When x is 0.999, the answer is what? 1.999. When x gets even closer, 9999. And it says the y value is 1.9999. It says, you know what? I drew my graph wrong. That's what it's telling me. It says it's getting closer and closer, so it didn't really dip down here. I took a guess on it. It says, no, you're not right here. You're wrong. It didn't dip down. As I get closer and closer to that value, where's the y value going to? 2, right? So this is the 2 here. Oh, this is the 2. I'm sorry. This is the 2 here. So that line kept going closer and closer and closer to 2 there. Should be a hole here. A hole because undefined. That's my hole. Make sure it's a hole. And let me look at the other part. It's probably going to happen the same thing on this end. It's going to be a straight line here. It's going to get closer and closer to 2. So let's look at it from the right side. What's the limit of f of x as x approaches 1 now from the right side? Again, from the right side, we're going to use values. Here we go. Choose values for x and find f of x. Now remember, you coming from this end toward the 1. Maybe I'll use the 2. I'll do the 2.5. Oh, what is it? Less than 2. You're going toward the 1. You coming from this end, the 1.5, right? Maybe the 1.1. The 1 point closer to that, 0.1. The 1.001. I'm approaching this x value. I'm coming down this way. I'm trying to hit x equals to 1 right there. I'm getting closer and closer to that number. What is going on? What value close to the 1? Well, 1.001 is very close to it. So I started from that end, and I'm moving my way here. With this, I started from here. I'm moving my way down to that value. That's the left side. So when x is 2, let's plug it in. What's the y value? It says, well, 1.3. When x is 1.5, the y value is what? Wait, did I put the 2 first? 2. When x is 2, the y is actually 3. So notice when x is 2, somewhere here the y value was 3. See it? When x is 3, not 1.33. When x is 1.5, the y value is what? 2.5. Right there, shrunk. See the y value? It's 2.5. When x is 1.1, you're getting closer now. That's a 2.1. Right there. When x is 1.01, where's the y value? 2.01. When x is 1.001, 2.001. Where do you see that number going toward? That's going toward the 2. Where do you see that number going toward? That's going toward the 2. So that's it. This value starts to decrease till approaches that 2. This one starts to increase till approaches that 2. So the graph, what the calculator gave us is really correct, except there should be a hole when x equals to 1. A tiny hole. Otherwise, it's going to be a straight line. When you do these limits, you're not going to have an answer every single time. But if the limit from the left side equals the limit from the right side, then we have a limit. So if the limit of f of x as x approaches the 1 from the left side, if it's equal to the limit of f of x as x approaches the 1 from the right side, then we have a limit. If they're not equal, there is no limit. And we can say the limit of f of x without saying left or right as x approaches the 1. In this case, the answer is what? Where's the y value going to as you approach the 1? It's approaching the 2. From either end is coming close to the 2. Can you see it? Toward the 2, the limit from the left side equals the limit from the right side. Do we always have a limit? The answer is no. I'll give you a quick one, doesn't have a limit. We'll do it graphically, we'll do it mathematically, and show you. I'll give you a simple one. F of x equals 1 over x. That's it. We know x cannot be what? 0. So let me graph that. Here we go. Clear it. I know what the graph 1 divided by x. I've done that thousands of times, but I want to show you. Oh, graph it. Here's the graph. Can you see it? Maybe not. Let me window enlarge that. Minus 3. Oh. Negative 3. 3. Negative 3. 3. Zoom in on it. Here we go. See the graph? So graphically, when you look for the limit, when I say what's the limit as you're getting closer to 0, this is what the graph looks from this side, and this is what the graph looks from this end. So where is the y value as you come to it from the left side? Where is it going to? Where does it intersect the graph? Where is this value? Notice intersector right there. What's that number? That's negative infinity. Way at negative infinity. And where is it from the right side? What is the y value as x approaches the 1 from the right side? Where is it going to? Infinity. So the limit, just based on the picture, the limit of f of x, we'll do it mathematically in a second, as x approaches the 0 from the left side, from the picture it looks like negative infinity is going toward the center of the earth. From the right side, as x approaches 0 from the plus side, it looks like what? Infinity. Are these two values the same? Is negative infinity the same as positive infinity? No, one is positive, one is negative. So the question now, what is the limit of f of x as x approaches the 0? And I didn't say left or right. Your answer is what? D and E. What is D and E? Does not exist. No answer. Does not exist. It doesn't have an answer. That's graphically. Mathematically, we're going to make a table there and see where the values are. I'll do it vertically, less space. This is from the left side, and this is from the right side. Let's see if it agrees with us. So I'm approaching the 0 from the left side. Here we go. X and 1 over x, or f of x, from the left side. So you're not at 0 yet. Maybe at minus 1. Then we'll use negative 0.5. Let's get closer. Negative 0.1, closer to 0. Negative 0.01. Negative 0.001. Let's look at it from the right side, from this end. You're coming, we'll start with the 2 here. Get to 1, get closer to 0. 0.5, 0.1, 0.01, 0.001. One over negative 1, that's minus 1. 1 over negative 0.5, negative 2, negative 10, negative 100, negative 1,000. Where's that number going toward? Do you see it getting bigger and bigger? With the minus sign, that's negative what? Infinity. If I get closer, 0.00001, it's going to be negative 10,000. 0.0000001, negative 1,000,000. From the right side, this is what? 1/2. This is 1. This is 2. This is 10. This is 100. This is 1,000. Where's that number going to? Positive infinity. That's what the picture told us. From the left side, negative infinity. From the right side is positive infinity. So what is the limit of f of x as x approaches 0? There is no limit. Does not exist. If I change that to x squared, there is a limit. If I change it to x squared, again, x cannot be 0. And if I graph that, you'll see there is a limit. Let me graph it here. 1 divided by x squared. Graph. Look at the graph. I don't know if you can see it. Yep. So this is what the graph looks like. From this end, it looks like this. From that end, it looks like this. So graphically, let's look at the limit as you approach the 0 from the left side. Get it close to 0 from the left side, close to it. Where's the right value going to? So what's the limit of f of x as x approaches the 0 from the left side? Where is it going to? Where does it intersect the graph at? What's the right value way up there? Infinity, yep. Let's look at it from the right side. As you get closer to this from the right side, you're getting close to 0, right next to it. And where's the y value going to? As x approaches 0 from the right. Where is it going to? Infinity. Are these values the same? Yep. So the limit, we can say now the limit of f of x as x approaches the 0 is equal to infinity. So we have an infinite limit. Approaches infinity. Table-wise, let's look at it again. I'll pick a few values from the left side and the right side. That's one way to find the limit, actually. And this is really the least attractive way of finding it. But in this example, that's the only way. X and 1 over x squared. From the left side, let's start with a negative 1. That's a 1. Negative 0.5. That's a 4. Negative 0.1. That's 100. Negative 0.01. That's 10,000. Negative 0.001. That's 1,000,000. So where's that number going toward? It's getting bigger and bigger and bigger. So it's approaching what? Infinity. Let's try from the right side. Let's try the 1. It's a 1. The 0.5. That's a 4. The 0.1, you're getting closer from this end. That's 100. 0.01, that's 10,000. 0.001, 1,000,000. And again, that number is approaching what? Infinity. Since the two values are the same, we do have a limit, and the limit approaches infinity. As I said, this is the least popular way to find the limit through the table because it takes a long time. But in this example, I really don't have any other choice. That's the only way to do it. If I give you other problems like the one you saw early, x squared minus 1 over x plus 1, there is actually an easier approach to that. I'll show you that shortly, without having to pick 10,000 points and graph it and all the stuff. Let me give you a picture and see if we can find some of the answers here. Let's say we have this picture. Making sure you understand how to find the limit graphically. And my picture looks like this. This function has a hole in it. Continues down. Back up here. Nope. Didn't do a good job with the back up here. Hole here. Closed circle here. Oh. We'll go like this, up to this point. I'm just throwing things close enough. This is minus 1. Let's say the y value here is 3. This is 2 here. At minus 1, the function has a value of 0. It's defined like this. Here we'll say it's negative 1. So here's my question for you. Few questions. Using that picture I drew there, what is the limit of this function? We call it f of x. What's the limit of f of x as x approaches the negative 1 from the left side? Just looking at that picture. Correct. 3. Why 3? Where's the y value? As you approach the minus 1, you're on top of the minus 1. I'm putting a space when I graph it because I don't want to clog it, make it look like messy there. Notice, what's the y value? 3, right? And as you approach it from the right side, what's the y value from the right side? There's the right side. What's that number? Still 3, right? So from the left side is 3, from the right side is what? 3. So do we have a limit as f of x approaches the negative 1? What's the answer? 3. Sure, because they're equal to each other. Looking at my picture, not the limit here, what is the value of the function at negative 1? When x equals negative 1, what's the y value? It's 0, right there. There's a closed circle. See that little hole? There's a hole up there, but there's a closed circle right there. So when x is minus 1, the y value is 0. So the function does not have to be closed to have a limit. It could have a hole in it. Now, is this function continuous? Not really, because there's a hole. In this segment, it's not continuous. You'll see that in a couple of minutes when we talk about, is the function continuous? There's 3 things must happen. The limit must exist. Well, we have a limit. It does exist. The function must be defined. It is defined. F of minus 1 is 0, but the third one, it says what? The 2 answers must be the same. If they are the same, this hole will fill in that, that dot will fill in that hole, and you have a continuous function. Okay, let's look at this picture. What's the limit, just in case you didn't get it yet, of f of x as x approaches the 0 from the left side? From the left side, the 0, we're talking about this y value. What's the y value? 0, right? From the left side, from here. Boom, it touches the line right there. From the right side, what's the limit from the right side? As x approaches the 0. You're not a 0 yet. You're up there, so what is the y value? Oh, crosses right there. What is that number? Isn't that a 2? Is there a limit now? What's the limit of f of x as x approaches 0? Does not exist. There's no limit. If the limit doesn't exist, the function can't be continuous. The limit has to exist, the function must be defined, and they have to equal to each other. If one of them fails, it's not. You can see there's a hole in it. Now let's look at the plot. Let's say this is 1 here, and this is a minus 1. What's the limit of f of x as x approaches the 1 from the left side? And what's the limit of f of x as x approaches 1 from the right side. From the left side, this is the 1 right here. From what's the y value right there? Is not equal to 1. The right side, that's also 1. Oh, negative 1, thank you. So what's the limit of f of x as x approaches the 1? That's a minus 1. The left side equals the right side. What is the value of the function as x equals to minus 1? I mean, as x equals to plus 1. I get the plus, the minus in my mind. Isn't that a minus 1? Notice that circle here is closed circle. When x is 1, the y value is negative 1. So that's how you find the limit graphically. You go to the point before that point and you see where does the graph intersect. The line intersects the graph. If it's a 3, that's what the limit is. If I want to find the limit at this point as you approach this point, let's say this is the point, I don't know, we'll call that that's a 3. And the y value for that, let's say it's 4. What is the limit of f of x as x approaches the 3 from the left side? From the left side, you're not at 3, you're just right before the 3. So you draw a line till you intersect the graph. What do you cross the graph at? What's that value? 4. And what's the limit from the right side? That's also 4. So what is my limit as x approaches the 3? That is a 4. Mathematically, we plug in points. That's how we do it mathematically, as of now. So I'll show you mathematically a couple of examples. Then section 3.2 is done. 2.2, I mean. Just don't ask me what today's date is, because I'm all confused. What's the limit of 3x plus 2 as x approaches, I don't know, somebody pick a number. Any number. 12? Okay. Let's see. The only method we know right now is pick points. Approaching the 12 from the left side. So let's approach the 12 from the left side and the right side. So this is x, and the y value will be 3x plus 2. You're approaching the 12 from the left. So you're not at 12 yet. Let's start with 11. Here we go. Let me just do this. What was that? 3x? 3x plus 2, right? The problem? Okay. When x is 11, I get 35. Let's get closer to that 12. 11 is far. How about 11.5? I got 36.5. How about 11.9? I'm getting closer to 12. 37.7. How about 11.99? 37.97. How about 11.999? 37.997. Where do you see that number going? Toward what value? Getting closer to what? 38. So from the left side, it's going toward the 38. Is equal to 38. Now let's look at it from the right side. So you're coming from numbers bigger than 12 and you're getting closer to it. What's bigger than 12? We'll start with 13 maybe. Where's the 13? Let's see, 13. It's 41. Let's get closer to 12. 12.5. I got 39.5. 12.1. 38.3. 12.01. 12.1. I might have hit the wrong key. 38.3, right? What about 12.01? Oh, 38.03. 12.001. 38 point what? 003. I can get even closer. But you can see that number is going toward what? Approaching what value? 38. It's getting closer and closer toward the 38. So the limit of f of x as x approaches the 12 from the right side is equal to 38. Since these numbers are matching, what is my answer to the question now? What's the limit of 3x plus 2 as x approaches 12? 38. Do I really want to do this table every single time? No. What's a quick way? How about direct substitution? Plug that number in. What's 3 times 12? 36 plus 2? 38. So when we get to the rules of finding the limits, the first step is direct substitution. If you get an answer, you're done. If you don't get an answer, you start looking for other ways. The last resort is really this method, because that's the longest way. That's my last resort. I'm going to be looking for shortcuts, quick way to get the answer. And direct substitution is always the quickest way to get your answer. So if I gave you this problem, find the limit of 4 minus x over 2 as x approaches 4. Try direct substitution first. If you have an answer, you're done. Let's see, 4 minus, when x is 4, what's 4 over 2? What's 4 minus 2? Is that a 2? Let's see if it really works. I'll test it again one more time just to show you that if I did a direct substitution or made the table, I'm going to get the same answer. You know, I put my videos on YouTube. One person sent me an email. Please don't waste too much paper.
Random person?
Yep, somebody on YouTube says, I love the videos, but you're wasting too much paper. Okay.
Hey, did you sign up for the pay-per-click thing yet?
The what?
You can make money off how many times people view your stuff. It's all original content.
Mine is not for sale, I told you. My stuff is, huh?
Yeah, you have a lot of views.
Yeah,
I mean,
you
they
could
get some
get
money off of it.
partnerships.
So right, I never made them for money. Have no intention of making money off them.
You put it back in the school that you want to do charity.
I'm telling you, nope, they're not for sale, and anyone wants to use them, feel free.
We got like 10,000 views in the video.
That's bucks.
That's a lot, yeah.
That's bucks, man.
For YouTube?
It's like 33 cents or something like that.
Okay, let's pick values as x approaches the 4. Let's start from the left side. 3.9, 2.05, 3.99, 2.005, 3.999, 2.0005. What do you see that number going toward? 2. Look at it from the right. Bigger than 4. How about 4.5? 4.1. 4.01. 4.001. 1.75. 1.95, 1.995, 1.9995. Again, where is that number going toward? 2. Direct substitution gave me the same answer. So you're probably not going to see me use this method for a while. I'm going to go to the rules. I'm going to try direct substitution. If it doesn't work, then I'll look for ways to make it work. Maybe, algebraically. If everything fails, I'll go back to this method. Okay. Stop this one, because on the next video we're going to show you the techniques we're going to use to find the limits.